Hello, I'm Gauri Nada. I'm going to solve a problem from 2014 Jan. The question is like this. Let S, it is from real analysis. Let S be the set of all x such that x power 6 minus x power 5 is less than or equal to 100. T is the set of all x square minus 2x where x is greater than 0. The question is S intersection T closed, bounded? Two questions. So the four options are S intersection T is closed and bounded. S intersection T is closed but not bounded. Bounded but not closed. So these are four options. So basically the question is it closed or is it bounded? So before solving this, let me just state a few theorems as well as results as well as definitions. So one is I want the definition of what is closed and open, obviously. And bounded, I think you know that. I'm not going to define that. Now, also, I need a definition of continuity, more than one definition, really. So, first, open sets. What's an interior point? Let A be a subset of R. A point X in A is called an interior point if there exists epsilon greater than 0 such that x minus epsilon to x plus epsilon, the open interval, is contained in A. If this happens for all, if each x in A is an interior point away, then we say that A is open. Okay. Now examples would be any open interval is an open set. So we can prove this, but I'll just leave it for the time being. I want to solve this problem. Now open rays. What is an open ray? It is either A to infinity or minus infinity to A. Open rays are open. These are examples of open sets. And one more thing, union of open sets is open. I'm not sure I use this, but let me just say that. Now next, what is closed? For that I need what's the limit point. X in R is a limit point of a set A in R. Take a set A in R. A point X in R is said to be a limit point of A if for all epsilon positive x minus epsilon to x plus epsilon, that is a symmetric open interval centered at x. This intersects A minus x. In A, you remove the point A, x if it is there. This intersection should be not empty. If this happens for all epsilon, then we say that it is a limit point. Now, a set A contained in R is closed if it contains all its limit points. Okay, so they are just the basic definitions, and I'll just go to the example immediately. Closed intervals of the form like AB and closed rays, which is of the form minus infinity to A, closed only at A, and A to infinity, closed only at A. These are closed rays. These are closed sets as well. So closed intervals and closed rays are closed sets. Okay, these are examples of closed sets. Okay, now coming to continuity. So let me show you what I'm looking. You can see this. Next. So let me show you. Let me give you the definition of a continuous map. F from R to R be a function. x0 belong to R. We say that f is continuous at x0 if given epsilon there is delta positive such that whenever mod x minus x0 is less than delta, this implies mod f of x minus f of x0 is less than epsilon. This is same as saying, though I am not going to use this definition right now, x belongs to x0 minus delta to x0 plus delta implies f of x belongs to f of x0 minus epsilon to f of x0 plus epsilon. Okay, so this is the epsilon delta definition of continuity at a point. If f is continuous at each x0 in R, then we just say that f is a continuous function on R. If it's continuous at each point, then it is continuous function. That's it. Now we don't use this definition. This is equivalent to the continuity definition of topology, which says that f is continuous if and only if for all open sets U of R, f inverse of U is open. And another equivalent form of this is that f inverse of C is closed whenever C is closed. So these are like very easy to prove the equivalence of these two. That is, inverse of open set is open or inverse of a closed set. These are equivalent things. So both of them imply that f is continuous, the epsilon delta definition. Now examples of continuous functions. First is polynomials are continuous. Polynomials are all continuous functions on R. Okay, this is all I need today to solve the problem. So let me come to what is S and T. So S is given to be the set of all x power, the set of all x such that x power 6 minus x power 5 is less than or equal to 100. Now define a function f from R to R by f of x equal to x power 6 minus x power 5. Then f is a continuous function because it's a polynomial. So inverse of a closed set is closed, inverse of an open set is open. Now, what is S? S is the inverse of this. Set of all x such that f of x is less than or equal to 100. So S is equal to f inverse of minus infinity to 100 because it is less than or equal to, it is closed at 100. So minus infinity to 100 is a closed ray, so it's a closed set. So f inverse of closed set is closed set. So S is closed. Okay. Now is it bounded is the question. Now let's look at the function f of x. X power 6 minus x power 5. So I can also write f of x equal to x power 5 into x minus 1, which is equal to I should talk loud. X power 5 minus x. So this goes to infinity as x goes to plus or minus infinity. Just observe this. If x goes to plus infinity, x power 5 goes to plus infinity, x minus 1 also goes to plus infinity. So the product, that is f of x, also goes to plus infinity. If x goes to minus infinity, x power 5 goes to minus infinity, x minus 1 also goes to minus, so the product goes to plus infinity. So as x goes to plus or minus infinity, f of x goes to plus infinity. Now, so what does this mean, going to plus infinity? That is, there exists m such that for all x greater than m, going to for all mod x greater than m. Mod x greater than m may say same as x is either a very large positive number or x is very large negative number. So x is close to plus infinity or minus, something like that. So if this is a definition of going to infinity. Okay, f of x goes to infinity as x tends to plus or infinity. Same as saying there exists M such that for all mod x greater than M, f of x is greater than 100. Mod. So f of x is greater than 100. So because f of x goes to infinity, that is, f of x does not belong to minus infinity to 100, or x does not belong to s, because s is f inverse of minus infinity to 100. So what have we proved? If mod x is greater than m, x doesn't belong to s, or s is contained in minus m to m. Okay, it's like the complement of this. Mod x greater than m implies x doesn't belong to s, or x belongs to s implies mod x is less than or equal to m. So this is bounded. This shows that s is bounded. Now coming to t. T is the set of all x square minus 2x such that x belong to 0 to infinity. So let g of x is equal to x square minus 2x, again a polynomial, so it's a continuous function. This time it is f g of x. What is t? T is equal to g of 0 to infinity, not g inverse, so I can't really use the continuity. But this is an easy polynomial, so we can actually find what is g of 0 to infinity. Now what are the zeros of this g? Easy to see that g of 0 equal to 0, g of 2 equal to 0. Okay, g of x is equal to x into x minus 2. That gives you x, the roots are x equal to 0 and x equal to 2. So it's a parabola. You can see that it goes like this. Okay. So now where is the minimum? What is the minimum? You can see from the graph, or from, you can see that it is going down. Anyway, I have already drawn the graph. So what is g dash of x? Is equal to x minus 2. So g dash of x is x minus 1, I think. 2 into x minus 1. So g dash of x equal to 0 implies x equal to 1. And g double dash of x is equal to minus 2 plus 2 greater than 0. So x equal to 1 is the minimum of g. So what is g of 1? It is equal to minus 1. So minus 1 is the minimum. From this graph, you can see that g of 0 to infinity is equal to minus 1 to infinity, minus 1 included, because g of 1 is equal to minus 1. Okay. So minus 1 to infinity. So this is a closed array, so it's a closed set as well. So I can see that T is closed. Now do I see that T is equal to g of 0 to infinity is closed but not bounded? I can see both together because it's a ray, it's not bounded, but it is closed because it's a closed ray. But we are looking at T intersection S intersection T. Because S is bounded, S intersection T is also bounded. Because both of them are closed, S intersection T is also both closed and bounded. This was the option.